Good morning, campers. Welcome to Unit 6, Coordinate Geometry. Yes, we're still there. But today it's Lesson 4. This is mostly designed for the people who were not here. Or if you just kind of want to watch the lesson again, we did it live, but now you can take a look at some, I might do a few problems a little differently. We'll see what happens here. But today the whole point was to construct and understand the equations of circles, which are all based upon, really, the good old distance formula. And we frame it out. And it looks like that. x2 minus x1. And y2 minus y1. All right, so going the distance. That's the whole point here. We are going the distance. So when Andre says, I know I can find the distance by drawing a right triangle and using the Pythagorean theorem, that's exactly what he's talking about. Two ways we did this in class. Number one, count. Change in y, right there, that change in y, it's really from 12 to 22. It's 10, but how we got there was really, to get there, you take that 22 and you subtract the 12. So that's the idea there. And same thing for the change in x over here. Change in x, from 53 to 8, or from 8 to 53, however you do it, it's still 45. But usually it's a subtraction thing. So if we did 22 minus 12, we would do 53 minus 8. All right, so it's kind of like an end minus start kind of idea. So really, if we know those two things, we can actually then write out the Pythagorean theorem. And that distance up here, which we call d, is really just 10 squared plus 45 squared. And I think that comes out to approximately 4609 if I use a calculator here. Oops, 4609. But really what we did, what even more important than that, was what we really did the whole thing. We really wrote it out like this. We took the difference of the x's, and that was the 8 minus 53. And we squared that, and we added that to the difference of the y's, which was 22 minus 12, or 12 minus 22, and we squared that. That's how we really got there. It's this idea that it's the difference of the x's and the difference of the y's. So that's going back to that same distance formula from the beginning. That is the distance formula. We're using that again and again, and then we take it a little step further. But first, who was the fattest knight at King Arthur's Round Table? Dun, 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 ding. That would be circumference. Get it? If not, forget it. Okay, 4.2. So now we're coming into circles, and by the way, a circle is defined as all of the points that are equidistant from the center. So here we have a center of 610 and a radius of 17. Looks like one of these points might be on the circle. So we could actually look at this and say, hey, 1425, it might be on the circle. 22.3 might be on the circle, but we need to verify it. So the whole point is that we're learning to verify, and that's what we want to do right now. Verify means check the distance. Check the distance between these 2 points, 610, which is the center, and 1425, which is any point that you think might be on the circle. Here's what I want to stress first of all before I go any further. If that radius is 17, well, if you get an answer where it equals 17, that means that point's on the circle. If it's greater than 17, that point is outside the circle. That's because the radius is too long. It's longer than the radius, actually. And if it's the other way, less than 17, it's inside the circle. All right, so just so you know, those three things right there, I'm going to erase these and come back to it for a moment. But that's the deal with the distance. That distance should be exactly 17 for it to be on the circle. Okay, so let's wipe that clear. And let's do some calculations here. Here's the calculation. Looks like this. all we're doing is checking to see if that's equal to 17. We're checking the distance. So I'm going to frame it up. Looks like the sum of two squares, because it is a Pythagorean situation. And I'm doing the difference of the x's. 6 minus 14. And that actually, 6 minus 14, is negative 8, but it really doesn't matter because it's going to be squared anyway. All right, and then you go 10 minus 25, and same thing. It's not really going to matter because we're looking at the distance, so it's always a positive number. So this difference, really, 25 minus 10 is 15, and that's going to be squared. All right, so if I do all that, and I run it through a calculator, this is where you're using a calculator, you're going to find that that does come out to 17. So therefore, it is a yes. I must confess it is on the circle. That's the deal. All right, so then if you run the other numbers, you actually run the other coordinates, 22 and 3. Take a moment on your calculator to do that. I've already done it, and it actually comes out to 17.46. So that one right there is a no-go. And that's because the distance is actually 17.46, which is greater. So it actually lies outside the circle. All right, so I'm going to pause the action here for a moment, take a deep breath, and look at what we've just done. We've just looked at using the distance formula to calculate that the distance between 2 points is equal to the radius. Okay, here's something we didn't do in class. We looked at the distance between all these points, and to do that, we really just looked at the coordinates more than anything else. So if G up here, let's say G is, what do we got? 3, 9. And let's go to B over here, which is 10, 5. Really just looking at the distance between those 2 points. So that's all that was happening there. And if you fill those in, I'm going to use my calculator real quick here, and I'm using a program for this, so it's going to take me a moment. So between G and B, the distance was 8.06. And the distance between G and A, well, let's see, the coordinates for A here are 2, 1. So we're looking at that coordinates there. So I can run my program again, and 2, 1, 3, 9. It's also 8.06. Really, this exercise is just proving that if you connect all the dots here from G to A, G to E, oop, that is really ugly. Let me make this a little bigger here for a moment so I can get a little more accurate drawing. G to A, G to F, G to B. What that's really saying is that you've got yourself equal distances. Equal, which makes that a perpendicular bisector. So that's really the point of that whole "are you ready for more" there. But the idea is that all those distances are equal. That's the whole point of equidistance, and we know about circles. All right, so now we take it just down to the whole enchilada. We know that the distance in a circle, we call it radius, so we actually use the letter R. And we know that this is the formula for it. We know it looks like the difference of the x's plus the difference of the y's, and they're both squared because it's based on the Pythagorean theorem. But now, if we're talking about this idea of center to radius, well, the difference of the x's really is just x minus that center of the circle, which in this case is -3. And y, which is any point of the circle, that's that coordinate. By the way, the y's, I'm looking over here, that's where I'm getting my x's and y's from. Y minus 6. And what we finally do with that, when we take it all the way to the end of this conversation, it doesn't matter what the center of the circle is, we just call it H and K. We can say any center H and K, so we can rewrite this formula as the radius is equal to square root of x minus h and y minus k. And then the last thing we usually do is square both sides. If we square both sides there, what you really get is you get the radius squared equals x minus h squared plus y minus k squared. And that truly is the equation of a circle right there. Make that a little more. That truly is the equation of a circle. The radius squared equals x minus h squared plus y minus k squared, where h and k are both the x and y coordinates of the vertex. X and y represent any point on the circle, and the radius is the radius. All right, so bottom line here, to check if a point is on the circle, we use the Pythagorean theorem to see if it's there. You can also use the distance formula if you really want to, but generally it's just, there's your h, 3, 1. That's a circle with a center at 3, 1. You just put the point coordinates in there, and if the radius is 5, you just want to see if that whole thing equals 25. All right. Question for today. Why does the formula use subtraction instead of addition for both x and y? And also, why does it matter if you put x minus 3 or negative 3 plus x in the equation? What's the difference? In other words, if you got it backwards, the result will be the same. But why do we really want to write it as x minus 3 and not minus 3 plus x? I'm going to leave you to answer those questions, and we're going to call it a day here because this video is getting a little lengthy.